All right, in this video, we are going to graph a polynomial function. We're just going to sketch the graph, but we're going to do this by using the zeros. So just to kind of outline what our process is going to be, we are going to first find the zeros from the factors. So find the zeros of the function from its factors. Then we're going to find the end behavior. And then we'll be ready to sketch our graph. Okay, so hey, good news. Our polynomial is in factored form right here. So the zeros of a function are when your function is equal to 0, and you can that will happen when your polynomial crosses the x-axis. So in factored form, what you're going to do is you're going to take each factor and set it equal to 0 and solve for x. This is using the zero product property that we've talked about before. We are going to get 3 zeros from this. Now, this first one you could divide by -1 and get just x equals 0. The second one, add 4 to both sides and you get a 4. And then the last one, subtract 3 and you get a -3. So what that means in a graph, maybe I'll just start sketching the graph over here, is that we have x-intercepts at these points. The x-intercepts are when your function is equal to a 0 because it's on the x-axis. So to plot these, we have an x-intercept at 0, we have one at 4, and we have one at -3. Okay, so we're going to sketch a graph. It would be very helpful if we knew what the end behavior of this was. Is it going to go up on the right or down on the right? Is it heading up on the left or down on the left? So end behavior comes from our leading term, which has the leading coefficient and the degree. Excuse me. We don't know what the leading term is from factored form. So we're going to go ahead and take our function and we're going to put it into standard form just by multiplying it out. So f of x equals, I'm going to start by distributing that negative x. We get a -x squared plus 4x. I'm going to carry down the second factor, x plus 3, and let's multiply this out. We get a -x to the third power minus 3x squared plus 4x squared plus 12x, and we have a couple like terms to combine. So standard form, -x cubed plus x squared plus 12x. All right, end behavior is going to come from our leading term. So the leading coefficient is a -1 and the degree is a 3. So here's how our end behavior works again. Always start with as x approaches positive infinity. That's the right side of your graph, positive infinity. You just saw I wrote a positive infinity over there on that side of the x-axis. Your y's are going to approach either a positive or negative infinity depending on the leading coefficient. Our leading coefficient is negative, so the y's are going to approach a negative infinity, which means our graph is going to head down on the right side. Then let's move on to the left side where we have x approaching negative infinity. So as x approaches negative infinity, the y's will approach. It's the degree that tells us about the left side. The left side is either going to be the same as the right, it's going to go down, or it's going to be the opposite, it's going to go up. This depends on if your degree is even or odd. If you have an odd degree, we will have opposite end behaviors, which means our graph is going to be going up on the left side, which means y will approach a positive infinity. Okay, now let's sketch our graph. We have an idea of what it's going to look like. We know it's going to go through those x-intercepts, heading up on the left, down on the right. So it's going to look something like that. At this point, we're not concerned with how high or how low these are getting when we're just doing a sketch of a polynomial function, but we've got our zeros of the function and we identified the end behavior and we were able to do a sketch.